There are so many techniques that can be used in chromosome manipulation. Chromosome manipulation is phenomenon where we, because of some reason, target a particular number of chromosomes. Now, for example, it is a situation, it is a phenomenon that we use to create polyploids in fisheries, for example. Now, we know of the types of polyploids. We have the triploid, the tetraploid, the pentaploid, and so on and like that. So, for example, if you want to create a triploid, now using temperature shocking. Now, to create a triploid in fish, what we basically do is this. After a normal process of inducing with hormone for production of egg and the process of extrusion of the egg. Now if you haven't watched the video I made on gametogenesis, please do well to watch so that you can understand what I want to talk about now. You know that from gametogenesis, that at the production of that egg, those eggs are at the meiotic 2 metaphase 2, at the metaphase 2 phase of the meiotic 2 division, second meiotic division. They are at metaphase 2 of that second meiotic division, meaning that they are not even they have not finished the final stage of division. So what we target is this. We want to use temperature shock to create triploid. Triploid simply means having 3 sets of chromosome, 3N. So normally, after cell division of the gametic cell, you should have haploid or haplontic cells. So now we want to create a triploid. How? By having an individual with a diploid chromosome plus the haploid chromosome. Now, in our practice of using temperature shock, what is going to happen is that the male will be haplontic, while the female will be targeted to be diplontic. And the male, so this is from the male and this is from the female. So the male is targeted to be is normal haplontic cell, while the female is targeted to be diplontic. And how do we achieve this? What we achieve, now this is going to give us 3N. Now how do we achieve this? Is after the first meiotic division, we know that there will be an extrusion of, so we have a 2N. After the first meiotic division, we know we are going to have a polar body, and this daughter cell that is being produced here. Now, so that is after this first meiotic division, we're going to have 2N after the first meiotic division. Now, what now happens is this. The daughter cell, this daughter cell is going to, now at the stage of fertilization. So for example, what we'll do is we are going to take the testis of the fish and add to the egg. After adding that to the egg, then we will now subject them to temperature shock. Now what happens is this. Remember that in that gametogenesis I told you that it is at the point of fertilization. It is in fact the penetration of the egg of the sperm into the egg that triggers the completion of meiosis division 2, second meiotic division. So at that point where fertilization takes place, meiotic division, second meiotic division would have started. So, and when second meiotic division starts, it's going to produce 2 daughter cells that are that don't have equal share of the cytoplasm. Remember this is the first polar body. So before it creates the second polar body, now it's going to create the second polar body after this fertilization. So on getting to this, it's called zona pellucida for the human. So this membrane here, as the sperm penetrates, the sperm receptor organs, receptors there. By the time it penetrates, the second division starts and the second polar body is being formed. But just before the second polar body is removed, is extruded, before extrusion, we subject it to a 0 degrees Celsius temperature and about 40 degrees Celsius temperature. Now beyond this, the eggs might not be viable again. So about 40 degrees Celsius and 0 degrees Celsius, the difference, we could separate them into different, we could use low temperature shock or high temperature shock. So if we use the low temperature shock, what that will do is that it's going to prevent the extrusion of this second polar body. Now you know that there is a secondary root site here. This is the secondary root site. Now this secondary root site is aplontic. The polar body is aplontic. Hence, these two altogether are diplontic. So because of the shock, the polar body will not be extruded. Now what does that mean? There is a diplontic sperm that is coming to fertilize this. Then when the polar body cannot be extruded and sperm has gotten there, it fertilizes, and then you have a 3N, which is a triploid. So that is one simple way of, well, it's not very simple, but it is one way of creating a triploid. You target just before the extrusion of that second polar body and shock either by high temperature or low temperature, and then you have two cells inside. So you remember that this polar body was, or podocyte, was to just remove the second, the set of genetic material so that it will not be double. So actually you now target it so that it can remain inside when the cell, that sperm fertilizes, and when it fertilizes, it produces a triploid. Now triploids are produced for many reasons, especially because of the fact that they have faster growth and they do not convert feed for gametic maturation, since of course many of them are usually sterile, right? And the sterility is due to the fact that these polar bodies will not produce a viable offspring. So adding the chromosome of the polar body with this and that is going to actually cause sterility in the triploid that is being produced. So this is the triploid. So that is the number of reasons why triploiding is being practiced. Alright, thank you very much for watching the video. I hope you did understood what I explained. God bless you. Please do well to subscribe to the channel once again. Thank you.